Hello once again, and welcome to Python Fundamentals. This is Module 3, List Iteration. Strap on your seatbelt because we are getting to the more powerful aspects of programming in Python. With this module, we learned already about iterating through a string in P2M1, Module 1 of this Fundamentals series. And the same concept will apply to lists, but the important idea is that when we get into a data structure like a list, we actually have more we can do with it. We've got more capabilities. And so we're going to explore all of those kinds of things. We're also going to learn about a function called range, which is pretty cool. It's part of Python. And what range does as a built-in function is it allows us to generate a list of numbers very quickly. And you'll see that. You'll see how that works. And then we'll start thinking about some of the other capabilities like sorting lists or splitting them, joining items to create a list. Lots of different things here. Okay, so now let's get started. To begin with, we've already seen how the in keyword can be used with a while loop with a list. We saw that in Module 2, and that was cool. This works just like you would expect it to. So if you have a list of things and you make a for loop that says for, like in this case, we see it down here. Here we have a list of cities, and we have for city and cities. It means you're going to tell Python to go through all of the items in the cities list one by one, refer to each item as city, and then for each one of those, do whatever the process is in the loop. In this case, it's just print city, which means it's going to go through and print each of these cities. And so in the example down here, if we run it, we see that it did exactly that. It went through each item and it processed it. Now we could have written all kinds of things in here. We could have said, for example, if city dot starts with in. So if it starts with, let's do M because we have two M's in here. So if it starts with M, then we'll do one thing, and then we could say else, just print city. And up here we could say, well, let's do print city dot upper. And now I can run it, and you notice Mexico City and Munich are now upper. So this gives us a quick way to just run through and do a bunch of stuff to a set of items and have it come out and process everything in order. So in is a really cool keyword there. And notice here we can also add things up this way. So we're processing and adding to the total all of the values inside of sales. So the total of all those numbers is 124. So it's very interesting how we can do that. Notice too that we can change the name of the iterator variable name. So this is like when we set the parameter in a definition of a function, we can make this whatever we want. As long as we don't get ourselves confused. So notice we have total here, total plus equals dollars. So this is going to refer to the items. So whatever's in the sales list, each item will be referred to as dollars when it gets processed. So we can then use the reference here and add it to the total. And it works. So perfect. I think you're ready to do this. So create a list of birds. You're going to create a list of birds, and then you're going to print each bird following this for in method. Create a list of 7 integers and print double the points for each point value. So then you're going to go through and write, print points times 2. something like that. And you'll turn it into an integer, of course, because you have to for a print. I mean, into a string. And then create long string by concat. So you've got a birds list, and so it says create a long string. So you just do string concatenation and then print out the long string with a space between. So I think you can do all of those things, and you'll see how the in keyword is useful. The for and in is useful for going through a list. Sorting and filtering is also possible with a list, so this is kind of cool. So here we can do it using a for in loop, and we can do a test here with an if. So if the length of the bone name is less than 10, then we can separate our list into shorter names and longer names and then print them all. And so there you go. And it's our foot bones example again. And then same thing here, we can actually, instead of doing plus equals like that, we can turn it into a separate lists. So we could do it that way. And now we've got separate lists. So it allows us to process data and then filter and sort it and make it into separate kinds of sources that can be used elsewhere. In my case, I do this kind of thing with data in my research when I need to split up different types of things or etc. So here you can do this, and notice print only cities starting with M. Well, that's just going to be an if statement in the loop. And sort into lists with A in the city name and without A. And so here you're actually going to do an if A in city, right? So remember, you can use that in statement way back to, remember the allergy tech in P2M3? Remember that? That's what you're doing here. You're checking to see if there's an A in the city name, and if there is, you're going to put it into your list of A cities. And if not, you're putting it into the no A's. So I think you can do that, but it's making you review content from a while back and bring it together into this task. So now we can do other things. We can count the total number of our items in a list. So here for city name and cities, we can count the number of letters. So you haven't necessarily seen this .count method yet, but we can do that. So cityname.lower.count. So it's going to change it to lower, and it's going to count it, and let's just see what happens. So the total number of A found in list is 6. See how it's counting the A's? What if we change this to an O and we run it again? So O, we have 1, 2, 3, 4, 5, 6. What about E? So if I change it to E and I run it, it says 3, 1, 2, 3. So you see how it's working? So I'm able to look for the total number of a given letter in all the items in this list very quickly and get a result. So I will switch that back. The total, I'll switch it back. There we go. And similarly, we could write that as a function. So we could say that our city search, we can tell it what to search for. We can make a default set of cities that we could override. And then if we find it, so city.lower equals, so it's looking to see if there's a match. And if it is, it's going to return true. So it's just going to search if it's there. So it's doing a complete match. So if we run this one, it's going to say complete match. So I got to do like New York. And it does do lower. So it says New York is in default cities true. It's in visited cities, and visited looks like it's got a little visited there. Little error is also true. And notice it's putting the result straight into a search function and using the result return straight in the print. So very cool. Easy to follow. And so here we're going to create a list called paint colors with 5 or more colors, and then we're going to get user input of a color, so you're going to ask them to give a color. Then you're going to go through and find out if the color is in there, and use the dot lower, so correct for upper and lower case. That'll be useful, and print it out. So you're going to make an example very similar to what we just did. The foot bones quiz, this time put it in a function, so use a def statement to create a function. And it's going to iterate through foot bones, looking for a match of a string argument. So this one is like this city search, whereas the other, so it's asking you to reapply what you just saw and learned and use this as your foot bones, so you can put that right down in here as the default. Bonus, remove correct response from the list if correct, so user cannot answer same item twice. So that's pretty cool. And it says call the function 2 times, so you could do that. You could even put this in a while loop and let them keep guessing, but I don't want to tell you too much because you're going to end up doing something like that in the practice and the required code. So this is really getting you ready for those kinds of things. A list iteration, so loops, we've done this for in type loop already. And now let's learn about how we can generate a range in order to do that. So the range is pretty cool in looping operations. Range stop function creates a sequence. It uses one argument, the stop. The default start is 0, and the stop is telling it where to stop. So notice if we did for count in range 10, it would create a loop by generating this list. So the range function generates an integer list by default. In this case, it's going to be 10 items because it's going to start at 0 and it's going to go up to 9. So it's 10 items, and range runs 0 through the stop. And so if we do that and then we print it out, look, we got 0 through 9. So range is a function that generates a list of integers. That's cool. We're going to learn a little more about how to make that more custom, but worth knowing right now. So you run the example and you take a look at it, and we can see digits equals range 10. So again, what did it put into the digits? When we printed this out, we can see what happened with digits. So it made digits into this guy. Now notice this little thing that says list. It cast it as a list. What if we take that out? What if I do this and I run it again? So here, it stores the method. It's not storing it as the list. Isn't that interesting? So again, if I want it to show the actual list, I got to throw the casting of a list onto it so that it's not storing the method as the digits variable. And that then allows us to do what we're wanting to do. So now, again, I can come through and we're going to have the 0 to 9 again, and we're going to add them all together. And so I do that, and I see that the digits 0 through 9, 1 by 1, added together is 45. And then down here, we've got a bunch of words. Find the length of the first half of the list. Look at this. So we can do the length function, and then we can divide it by 2 and use the integer to round it. And then for word in range, and we're feeding it the first half. So let's roll through that. And we can print just the first 3 because it rounds down to 3. We had 7 items, but when we ran the integer, it rounded the 3.5 to 3, and then we got those 3 items. All right, so I think you're ready. So you can go through and write these guys, multiply the numbers 1 through 7. Now, if you're multiplying 1 through 7, there's one little thing I want you to remember here, is that we have a problem. Watch this. If we do for num in range, and what if I just put a 7 here? Like that. And I do this. I'm going to do num equals num. So if I'm going to multiply them, let's go ahead and times result. So the result is going to start as a 0. And let's just do this. Well, let me think about that. So let's do result equals, we'll even start with 1. And then num equals num times maybe times result. Now, what I want you to think about is what happens when you multiply something times 0. And then what are we going to do? We're going to store this in the new result. If I do that, and then I come down here and I hit print result, I'm going to get a 0. What if I do plus? What if I do plus and I run it? I get 22. And keep in mind what's going to happen if I print the result each time. I see how it built up. Now, if I need 7 to be in there, then I got to go to 8, right? Now I got 29. But it turns out we can actually do a start value. What if we start at 1 and we go to 8? And we go down here and we type num plus result like that. And then we do print like that. I'm going to watch this. I'm going to put this right here. And then I'm going to do something funky. I'm going to, in the print statement, I'm going to put an end. Instead of a line feed, I'm just going to put a space so that it prints it all on the same line with the next result. So the value of the result is going to change in between. So I'm going to get an equation, and I'm going to do, let's do result, and then I need to do down here equals result. 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 4 is 7. Do you see my numbers are coming? 4 plus 7 is 11, and then I get 29, and so I've added 1 through 7. This time I have no 0 because I started on 1 instead of 0. Could I now change it to multiplication? So let's try it. Let's put a times in here and run it. And now I've got 50, 40, but only because I changed this from being a 0. By default, if I just do range 8, it starts at 0. And I'm going to get zeros everywhere because it's going to be a 0 times everything. So I need to be aware that it's going to start on a 0. So for multiplication, I have to start it there. All right, I'll take that out and let you work on that yourself. Now print the second half. I think you can do that. And notice range start stop is here. You really need it up above, which is why I just explained it. But I think you've got it now. You get the idea. Range 5 to 10, and then you can go ahead and print. It allows you to start on a different number. So we can go ahead and print the example. We can start on 5, go up to 10, but not include 10. And notice here the subtotal. So again, we can make it start on 5 and go through. And down here, we can use the same kind of thing to print the last half. So in here we actually started, so look, range half 1. So we told it to start at index 3. Index 3 is 0, 1, 2, 3. So it started on November and printed the rest, the second half of this list. So that worked out well. And I think you're probably ready for these guys. And here it says use append, so it's getting you to use some of the prior knowledge. Over here, print the third, fourth, and fifth works. Again, range with a start and a stop. Using code, find the index of annual in the spell list. So this one, if you do a for in loop, there is another way to find index. Index actually has a special, it actually has a special method. If you've been looking at our, over here, if you've been looking at our list object methods in the cheat sheet, you may have noticed that you can use .index to accomplish this task. But since you haven't explicitly learned that, you would do the task here by running a for in loop, and you would look for, at which number in the range this particular word occurs, where you run into a match as you go through the items, and then you would report that index. So you could do it that way, but you could also use the .index method to do the same thing, and it would find the first occurrence of that item in that list. Range, start, stop. Now, just like with the slicing we did with strings, we can have a step function. So we can tell it to jump using 10s, 1s, 2s. So we can go every 5 items down here. We can go every 25 items. So we can go in here like this, and we can start at 25 and go up to 101, which means include 100. And we can count by 25s. And similarly, we can count by 5s down here. And so we can go and go up by 5, starting at 25, and add it all together. There are a variety of kinds of uses for this kind of logic in programming when we're solving real problems. And so understanding how you can control the iteration through lists by generating a range index list is quite useful. Down here is similar. So look, we're going through and printing every other day. There you go. Or I mean every other item in the list. So we just jump through, and then we can do this is very similar like that. We can generate a list of numbers 1 to 20 going every other one and print it out. And so we can generate a list of odd numbers very quickly, which is super cool. Here, print numbers 10 to 20 by using 2s in a range. That's just start, stop, and step. Print numbers 20 to 10. Here we're going to do, we're going to start at 20, go down, stop at, I guess, 9, and it would be by -1 would be our step, which we saw with strings. We could make our step negative and go reverse. So we can do that here too. And then print first in every third word. So you can do that you got. What else can we do? So there are some more cool things we've got here as options. So when we start looking at, here, complete a list of letters program, test the word complexity, input a word string, find the string length, so it's just the length function, use range to iterate through each letter in the word. So we can do 4 letter in range, and then you're going to use the length of the word as the stop. Then save odd and even letters to odd letters, and then print them. Absolutely something that you saw in the examples up above. You can definitely do it. The error down here, type object is not subscriptable. So notice what happened here. Range is supposed to be done with parentheses, but we've got square brackets. Know how to solve that? Need I say more? I think you've got it. Power of list iteration. So there is even more we can do with lists. So when we start getting down in here, we can do list addition. We can extend lists, which means taking one list and putting it onto the end of the other. And it's just really lots of options here. So we'll see how those two work. So for example, if we have visited cities and then we have wish cities, and we can make a combined list by just using a plus. And then that makes a new list called all cities. If we wanted to just put them all into visited cities, we can do that by using extend. So if we use addition, it makes a new list. If we use extend, we can add one list to another list. So down here we can see that. Down here we can see what extend does to get all cities. There it is. And if we use visited cities plus wish cities, then we go down here and we can see that it created this new list, all cities, and they are all in there. So it does something kind of similar. It's just a difference of whether you're going to put it into a new variable or you're going to put it into an old one. So if you want to just add it to an old existing list, you'd use extend. If you want to create a new list from two lists, you would use addition. Here, team A and B, you can do team totals, there you go. If you want to put them all like that. And notice the little hint here, what if you keep running this cell? It will keep putting it onto the end of the list. You see that? So this is interesting behavior. It allows us to keep growing it if we need to keep adding a series of things to a list every time some event happens. We could do it. And that is a possibility in a variety of scenarios too. Like if we're logging people coming through the door at our store and we've got some details about how long the door was open or something, and we're trying to get a sense of how many customers are present, we could capture all that data into a list, and then analyze it at some point. Extend the list. You create a bird scene and then you use extend down here. I think you can do this. Notice create two lists, 0 to 9 and 10 to 100. And you do that with range. So you'll create lists with range. And that's simply, we've seen some examples of that up above. And then use list addition to put them all together and print. Cool. Reverse. So this just reverses a list in place. Now this little phrase in place is important because it means that it actually takes the list and modifies the list to be in reverse. So we can see that the very same list became, when we printed cities 1 after running the reverse method, it was going the other way, right? So it swapped it. So when you see this in place reference, it means that right there in the memory, the actual storage is going to be reversed and saved in reverse. And so here we can see we've got a bunch of numbers. We can reverse the list and then print 3 multiples for num and all nums if num divided by 3 equals int num. So in other words, if there's no remainder, print the number. And so we can see here we've got the 3 multiples here from our list. So here we had a bunch of numbers and here are the ones that are multiples of 3. So we were able to very quickly screen through and conduct what is a somewhat in-depth logical process and have results come out quickly. Review and run the example. So here, notice list range 21. There's where we're generating a list again. And we can go ahead and we generate the list and then we run it in reverse. So reverse is pretty cool that way. You should be able to run these examples. I think you'll be okay on these. Multiples of 4, we just did multiples of 3. So you can go up and see that example and go through those. And then it says mirror the output. So this takes a little more thought. You're going to want to count down and then you'll run logic to count up in order to make that list work. Or you could do addition to create a new list. You could have one and then reverse it and then add that and have both in one list. So there are a couple ways you could do that. You should be able to work through that and be just fine. Now, we talked about in place, and similar to what we did before, remember you could use extend or you could use list addition. And if you used extend, it changed the variable in place. It changed the list in that variable name in place. And same thing with sort. Sort is going to sort the actual values in the saved variable. Sorted is going to generate a new copy. So if I use sorted and I put it in a new variable, it's going to put it in over there. If I just run sorted, it returns that, but it won't change the original unless I store the result of sorted into game points. Then it would actually overwrite what was in there to begin with. So if I run this down here, I see the quiz scores.sort and I print it, and now it's got it in order. It wasn't in order, we see that. And now if I run sorted down here, I can see that game points and then sorted game points, and you see that game points remain the same, but the sorted is actually sorted. So that works too. Then down here we've got some unsorted cities, and then we've got sorted cities. So these are examples so that you get a feel for how it works and how the sorting works. And here the sorting is happening using the ASCII sorting that we learned about way back with the punch card. Dot sort and dot sorted, I think you're ready to try these out. Now merge is another interesting one. So you build a list like with add animals. So here we can build a list, add animals using a while loop, stop adding when an empty string is entered. So while stop adding when an empty string is entered. So if I say next animal is not equal to, actually we could do this a few ways. I could do a while true loop, and then I'm putting this in because it takes a little review. So I could do a while true loop, and I could say next animal equals input, give me an animal to add or blank to stop, like that. And now if next animal equals blank, I can run a break, else I can do add animals dot append next animal. And now I've got a loop that when I run it, I can put in J, cat, dog, lion, or lio, and then hit blank return, and it ends. But that's now part of my list add animals. So if I come down here and I do print add animals, oops, and run it, oops, not ass animals. I got a little mistake in the typing there. There we go. There's my animals. Extend the lists into animals, then sort. So it says to put, so now I want to do animals.extend somewhere down here and make it all into the animals list. So I think you can do that. And then allow animals list to be viewed alpha or reverse alpha order. Get input if they want to see it, and based on that, if alpha, then print that way. If not, print reverse. So I think you got all of that. You can do all of that. For and in loops we've been looking at. We've seen a number of these different pieces, and now we're going to learn about split and join, which are pretty cool. Split So converting a string to a list with split. So actually it will split a string at spaces to create a list. So notice here, if we had a sentence, we can split by default. We can take this thing, it's not going to do it in place, it's going to do tip.split is going to generate a list of tip words. And so we can go down here and run it, and we can see that it changed it into a list. Started as a string, it made it a list, and then we were able to iterate through it and do things. Similarly, here we see we can do the split and then reverse and print. Down falling is Bridge London. So we were able to use the list methods after we turned it to a list. And so that gives us some power in terms of working with things that are strings. We can convert them to a list and then use list methods to work through them very, very quickly. I think you've got that. I think you can do this one. You'll be okay there. To split on characters other than space, provide an argument. So we can actually tell it where to split. So we can split it on the right here. We could use a dash. So if we come down here, we can see that's working. And if review and run example, here we're splitting on A, so here's an A. So if we go ahead and do that, we can see that we can use an A as a split, and the A doesn't get included, it gets taken out. So just think that's how that works. That's how split works. So triple quotes preserve formatting, spaces and line breaks. So if we want to, if we come through here and we do big quote dot split on the line break, and then we print quote lines and we put the line breaks back in. So we split it on the line breaks and then we printed it again. All right. Let me go in here and type in so we can see which is which. So if we just print it like this, we don't see the line breaks. They're not part of the quote. If we go back through though and we print it in reverse, so here's our, remember, we can do quote lines. Quote lines is a list, and we can iterate backwards through it, and then we can print each line, and that will give us backwards, and now we have each line, and so then we see it. So print each phrase on a new line, title case, so that's just dot title. You're splitting it on the asterisk. I think you're ready for that. Join. Now join is pretty cool too. And we're getting to the end of learning about list iteration and the power of it. There are more things you can do with lists, but this gets us pretty far along in terms of learning how to do things. So here, join allows us to build a string from a list. So what join does is you tell it what to use for joining the list. So you start by telling it, for example, put a space between everything in the list. And then you tell it which items to join. So it's a little funky in terms of how you write join, you know, the actual syntax of using this method. So notice it's a string, and you're going to then, this string method .join takes a list and puts all the list items joined by the string that you gave it. So now I can come down here and say we can run this example, and we had all these words. Notebooks can be exported as PDF. It joined them all with spaces, and it made a sentence out of it. Down here we can come down and we can just join the letters, and we can use a special no space which is defined as blank, and if we do that, we get our original string back. And then down here, we can join with ellipses or iteration, whatever we want. So notice we can join with a dash, we can join with a space, we can join with ellipsis, lots of options. So I think you're ready to run those joins. I showed you using the end earlier, but by default, the print function ends with a string feed, but you can tell it to just print on the same line essentially. So here we've got a hello letters, and then we can come down here and make a list out of concatenates and then put a squiggly in a tilde in between each letter. So that's kind of cool. Here, notice if the end is a blank, then we can make two print statements in the same code block send their content to the same line without a line feed. The line feed is the default. So by default, if you don't have to type this, that is the default for the print function, and it's a defaulted argument. So by default, it always does that. It puts a line feed between print statements because it puts a line feed at the end of every print. But if you tell it to do nothing at the end, then it will allow you to print two different print statements to the same line. And then we can come through here and we can see how that works different ways. And voila. Anything else here? So I think you're ready for these guys. Add the digits. I think you're ready. So have fun. Hopefully you can start to see some of the power. Our ability to go through data and perform operations on it is absolutely critical for getting the value out of code, and you are stepping into that in a big way here with list iteration and the methods you've just learned. They may seem kind of abstract at this point. You'll see in the practice and required code, they'll take you into a little deeper examples. But these are the keys to where big data is going and how companies can take all sorts of data that they have and process it and find different unique aspects to it, run analysis on it, all of those kinds of things. So as you go through this work, hopefully that's ringing true for you so that you don't get demoralized or discouraged, because you got to keep up your efforts and keep trying, work through the errors, post where you run into trouble, document, reach out, help others, and you can definitely learn all of this. So with that, we are wrapping up Python 2 Module 3.